Good afternoon. We are here with the lecture number 4 of the Networks Analysis and Synthesis, that is KWE 403 course. In the last lecture, we have seen the incident matrix. So, there is some properties which we have written. Now, we will discuss the properties of it. This is the example which we have discussed earlier, and this is the incident matrix which has been made. Actually, the incident matrix is denoted by capital A subscript A. So, it is the A subscript A, it is the incidence matrix. Now, the property says that the sum of the columns is always equal to 0. It means कि whenever there is a node and a branch is coming, it is coming and going. It is basically the KCL law following that how much the current is coming, the same current is passing through it. So, the sum will be always 0. So, we can see that the first branch, one branch is incoming for a node and the same branch is outgoing for the another node, that is why the sum is always 0. We can see that the branch number 1 is incoming for incoming for node number 1, while the branch number 1 is outgoing from branch number 4. So, 1 and 4, the summation of this first column is always equal to 0, minus 1 plus 0 plus 0 plus 1, that is equal to 0. Similarly, for the second branch, it is also equal to 0. For the whole column, it is always equal to 0. This is the property of the full or complete incidence matrix. Now, come with the example. We have given a complete incidence matrix. It means it is given that A subscript A. This is given. This is the incidence matrix given. We have to draw the oriented graph. Oriented means with direction, right? So, we will see that there is branches 1, 2, 3, 4, 5 and 6 branches are there, and the nodes are 1, 2, 3 and 4. So, n is equal to 4 and branches is equal to 6. So, we will just initially plot the initially we will just denote the nodes. We will just name it as 1, 2, 3 and 4. 4 nodes are there and the 6 branches will be there. First, we will see whether the summation of all the columns is 0 or not, so that it is a complete incidence matrix or not. So, we can see that first column is 0, second column is also 0, summation of the third column is also 0 and so on. So, it means it is a complete incidence matrix, right. So, here we are going to plot the graph related to this incidence matrix, right. So, I will just now we will see this first branch is in between 1 and 2. It means that branch number 1 is in between 1 and 2. This is branch number 1. Now, for the orientation, it says that it is for first node it is minus 1. It means that for the first node it is moving inward, right. That is why it is minus 1. For the second node it is plus 1, means it is outgoing. As we have seen the convention, if a branch is going outward, then it is plus 1. If a branch is moving towards the node, it is minus 1. This is the convention we have followed for making the incidence matrix. Same we will follow. Now, for the second branch is in between second and the third node. Second and the third node, there is branch number 2. Now, for the orientation, for the second node it is minus 1. Minus 1 means it is moving inward for the second node, while for the third node it is plus 1. Third node it is plus 1 because it is moving outward, right. Similarly, for the third branch, it is in between the branch number 3 and 4. 3 and 4 is this branch, it is branch number 3. For the orientation, for the node 3 it is minus 1. It means that it is moving towards the node number 3. So, it is minus 1 and hence for node number 4 it is plus 1. Now, for the fourth branch, it is in between node number 1 and 4. So, in between 1 and 4 we will connect and we will name this as a fourth number branch, right. So, for first node it is plus 1, it means it is moving outward from the first node and it is incoming for the fourth node. See, it is outgoing for the first node and it is incoming for the fourth node, right? For the fifth branch, it is in between node number 1 and 3. 1 is here and 3 is here. So, there is a branch between node 1 and 3. Now, the orientation for first node it is minus 1. It means ki for first node it is moving towards the node number 1. So, for node number 3 it is moving outward. So, this is the oriented graph which we have made, one more branch has been left. This is the branch number 6. It is in between node number 2 and 3. So, there is one more branch which is left, branch number 2 and 4. This is branch number 6, right? And for the orientation, it is minus 1 for node number 2. Node number 2, it is moving inward. So, this is the complete oriented graph for this incidence matrix. This is how we make it, the complete graph with the whole orientation, right? So, this is how we make a graph from an incidence matrix, and we have seen the incidence matrix also from the oriented graph. Now, the reduced incidence matrix. What is reduced? As the name suggests that it is something related to incidence matrix which has been reduced, right? So, it is a matrix obtained from A subscript A, that is incidence matrix, by eliminating one of the row. It means we have to eliminate any row which we take is as a reference node, and we will just eliminate it, and then it is denoted by capital A. Now, if the graph is not fully connected, or in general we have to find how many number of trees are there, then the formula for number of trees is determinants of the matrix A into A transpose. This A is actually the reduced incidence matrix, means complete incidence matrix by eliminating any one row which we will take it as a reference node. We will eliminate it, then we find the reduced incidence matrix. We have taken the same example, we have seen here the same graph and the same incidence matrix which we have taken here. Now, what we will do, we will take any row as a reference node and we will just eliminate it. For example, if I am eliminating this row, now it will make a reduced incidence matrix. So, it will have 3 nodes, that is 1, 2, 3 with values, same values, we will not change anything in it. We have just removed one node by taking it as a reference one. So, this is the reduced incidence matrix, right? I have said one term, that is the fully connected graph. Fully connected means each and every node is connected with the other nodes, then it is called the fully connected. For example, if same example we will take, this is the oriented graph which we have always taken for all the examples. If we see, all the nodes are getting connected with each other. One is connected to 2, one is connected to 3, one is connected to 4 also, and similarly 2 is connected to 1, 3 and 4, similarly for the third and the fourth. So, it is the fully connected graph, right? So, for fully connected graph, the number of trees can be obtained by using the formula n to the power n minus 2, right? If it is fully connected, then only this formula is applicable. Otherwise, in general, whether it is fully or not fully connected graph, the number of trees is determined by the determinants of A into A transpose, that is the reduced incidence matrix, where A is the reduced incidence matrix, right? So, if we take it as a fully connected, now if I remove any one of the branch, suppose I have removed this branch. Now, one is connected to 2, one is connected to 3, one is connected to 4 also, but one is not connected to 3. So, it is not fully connected graph. So, number of trees can be obtained by this formula, right? Now we will see the example of the reduced incidence matrix. Now example says that draw the oriented graph from the given incidence matrix. As in the previous example we have seen, here it is written complete incidence matrix, but here it is not written. So it means it is not a complete incidence matrix. We can check it also. The summation of all the columns should be 0. Here we can see the summation of the first column is not equal to 0. It means it is a reduced incidence matrix. It is actually A, right? So we will make it a complete incidence matrix by adding one row and putting the values accordingly, so that the sum of the column should be 0. It means for the first column, the first entry is -1, second also it is -1, for the third also it is -1, fourth also it is -1. For the fifth branch it is already 0, so we need not to put any 1 or -1. For the 6 also it is 0, 7 also and 8 also, right? So we will just name it as node number 1, 2, 3, 4 and 5, and the branches as 1, 2, 3, 4, 5, 6, 7 and 8. Right now we will just plot the graph of it. We will take any oriented type of nodes. It could be anything according to your choice. This is node number 1, 2, 3, 4 and 5, right? This is the node, 5 nodes which we have taken. Now for the first branch, it is connected between node number 1 and 5, right? 1 and 5. So node number 1 is connected between 1 and 5. So 1 and 5 will get connected. It is branch number 1, right? Now for the orientation, for the first node it is +1. It means for the first node it is outgoing, right? That is why it is outgoing. For the fifth node it is incoming. Obviously it is -1 here. For the second branch it is between 2 and 5. For the second branch it is in between 2 and 5. For the orientation, for the second node it is +1, so it is outgoing for the second node. For the third branch it is in between node number 3 and node number 5. 3 and 5 is branch number 3. For the orientation, 3 is positive, it means for third it is outward. For the fourth branch it is in between 4 and 5. 4 and 5 is connected like this, it is branch number 4. For the orientation, fourth node is +1, so for the fourth node it is going outward. For the fourth it is incoming. For the fifth branch it is in between 1 and 2. 1 and 2 is connected like this and it is branch number 5. For the first node it is +1, so it is moving outward from the first node. For the sixth branch it is in between 2 and 3. 2 and 3 is connected like this, it is branch number 6. And for orientation we will say 2 is positive, it means for the 2 it is moving outward. For the seventh branch it is in between 3 and 4. 3 and 4 is connected like this, it is branch number 7. For the orientation, it is third node is positive. It means for the third node it should be outgoing, and for the fourth node it is incoming, right? Now for the 8th branch it is in between branch number 1 and 3. It is in between 1 and 3, it is like this. This is branch number 8, and for the orientation, +1 is for node number 1. It means for first it is outgoing. So this is the oriented graph of it. This is the oriented graph of this matrix, right? So we can see that first node is not connected to fourth. It means it is not fully connected graph, right? So this is how we prepare a graph from a incidence matrix, and from the graph also we can make the incidence matrix, right? Now the next topic is Coset Matrix. As we have seen the concept of coset also in the previous lecture, so now we will make a coset matrix, right? So coset matrix is a matrix which contains coset as a row and branches as a column, right? So the coset matrix is denoted by this symbol Q and F. Q subscript F. F stands for as the fundamental cut set, right? Now there are certain steps. Steps for writing the cut set matrix are: first we have to draw the graph from the given networks. Now draw the tree and the and the tree branches are called the twigs. Draw the remaining branches, which is the core tree, and they are called the cords or limbs, right. Next is each branch of the twig, each branches of the tree will form an independent cut set, right. We have already seen. Write the matrix with rows as a cut set and columns as branches, right. And we have seen the direction of the cut set also. So, we will take it as example. Now, we will see that, right. So, same example I have taken for the oriented graph. Now, we will take tree as this. This is one tree which is connecting all the nodes, but there is no closed path around any node, right. This is the tree. Now, what are the branches? Branches are the which are left, they are the core tree, right. So, we will show it by a dash lines. This is core tree branch, right. We will just give the orientation also 1, 6, this is 3, this is 2, this is 4, and this is 5, right. So, now for making a cut set, we have already seen that cut set is a set which is going to divide your graph in two parts, right. And the cut set contains only one tree branches, right. So, we will just take the same example which we have seen while studying cut set also. We will take, this is the first cut set, this is C1, right. This is C1 cut set, and the direction of this cut set is same as the direction of your tree branch, that is the twig. It means it is going outward. So, the direction of your cut set is also moving outward, right. So, we will write the fundamental cut set, that is C1 is having a branches, it is cutting branch number 1, 2 and 3, 1, 2 and 3, right. Similarly, for the second cut set, we can say here is the second cut set which is passing through one twig, one branches of the tree, and its direction will be same as the branch of your twig. So, it is also outward as the direction of your branch number 4. This is C2. So, C2 is having a branch number 3, 4 and 6. Now, for the last cut set, that is cut set number 3, it is having the same direction. It means it will follow the direction of your twig. It means it is like this, right. So, the C3 is containing the branch number 1, 5 and 6, right. Now, we will form a matrix. As I have said that the matrix will contain the row as your cut set and branches as your columns, right. So, C1, C2 and C3 will be the rows, and 1, 2, 3, 4, 5, 6 will be the branches, right. Now, for the cut set C1, here, for it will also have the entries of 1, -1 and 0, nothing else than that. It will have the same values 1, -1 or 0. 1, for 1 it will, if the direction of your tree branches or core tree branches matches with the direction of your fundamental cut set direction, then it is 1. If it is opposite, then it is 0. If no branches is cutting through this cut set C1, then it is 0, right. So, as I have said, this cut set C1 contains 1, 2, 3 branch, it means ki 4, 5, 6 will be 0. Now, for the first branch, it is having opposite direction. See, it is going outward, but this first branch is coming inward. So, it is not following the same direction. So, it is -1. For the second branch, it is in the same orientation with your cut set. So, it is +1, and for the third branch, it is also same see the direction is same with the cut set. So it is +1. For the C2, it is passing through 3, 4 and 6. It means ki 1 is 0, 2 is also 0, it is not passing through the second branch. For the third, it is outward, but the third branch is inward, so it is opposite, that is why it is -1. For the fourth branch, it is following the same, so it is 1. For the fifth branch, it is not passing, that is 0. For the sixth branch, it is same, so it will be 1. For the cut set number 3, we will see for the cut set number 3, the branch 1, 5 and 6. So 1 will have the direction as this, but the cut set, fundamental cut set direction is opposite, so it is -1. Second is not passing through this cut set, third branch is also not passing, fourth branch is also not passing, fifth having the same direction of your fundamental cut set C3, so it is 1. 6 is also matching with the C3 direction, so it is +1. So this is the fundamental cut set matrix, that is denoted by QF, right? So this is how we make a co-tree matrix. As I am taking always this tree, the second tree we can take it as this also. 1, 2, 3, all nodes are connected, but no closed loop is there, right? This is the another tree. So we will take the example of it for making the code tree. Now we will just draw the code tree with the dotted lines. Now for making the cut set matrix will pass it through the only one tree, right? So this is first cut set C1 and it is having the direction of the same branch which we have taken, that is the twig branch. This is first is going inward, so it will have the direction of inward, right? This is the second cut set matrix, and for the third cut set matrix it should be passing through only one tree branch. So the third cut set matrix will be like this. This is passing through this branch, this and this. So red is the tree branch, so it is passing through only one tree branch, that is why it is cut set which is C3. So it will have the direction of your tree branch, that is 2, which is inward. So it is like this, and for the next branch it is 4th, right? This is passing through this, so its direction will be outward. So this is how the direction we will take, and we will make the cut set matrix QF by using the same concept as we have taken. Thank you. We will proceed next.